Okay. Hi everyone, welcome back. So hopefully everyone's gone through the exercises so far. I've had a couple of questions, so I should go through them and try and give some more clarity to some aspects of it. And all the questions have been about indexing and indexes. So the first question was about here, this example. Unfortunately, let me just make that easier to read. So this example here where we're ensuring an index, and why might you use ascending and descending or different sort orders for a compound index? So the main reasons for doing this, and this is quite a simple example for the scores database, but the main reason is if you are doing queries over large data sets and you are sorting the results that you're getting back, you could use the index to help maintain the sort order as well. So you don't have to get the documents that match and then manually sort them. If they're already in the index in the B tree in the correct order, it's a quicker operation. So that's where you may use or may decide to use like ascending or descending orders for your indexes. The next question that I got was about people notice when you added an index in this training and the scores collection that using the index actually slowed down performance. So that's not too unexpected here because we only have 3,000 documents, so there's not that many. And if they're all in memory, doing a query and going through them is going to be fast. If you're using an index and have to go through an index, you're going to go through the index first, and then you're going to go and find the documents on disk. So with small data sets, potentially you could add a millisecond or two, I think people have seen, where actually using the index has made it slower. But when you have large data sets, obviously the indexes will make it faster because it won't have to scan through the documents themselves. The final part is how MongoDB determines which index to use. So when you've done your explain commands, you'll notice as you add more and more data, it may switch which indexes it uses. So by default, MongoDB has no query plan code at all. So when it first sees an operation, a query, it will run it in multiple threads against all of the indexes. And the first to return is the index it will use for a period of time. The other threads will just be terminated, and it will determine to use that index for short periods of time. So this is useful because obviously the most performant index for any given query, depending on the values that you're querying, will be used for you and will be used for the next period of time. But as you add data through and as you get larger and larger collections, you'll see, or you may see, that when you do an explain later on, it uses a different index. So depending on your machines and things, you may see different query plans that have come through. When you've done the explain, it's used cursors that you wouldn't necessarily expect. So if you used, for this one we did a score and a name, and if you did a query that limited by score and sorted the name column, it might actually find that it's not using this compound index, it might just be using another one because that ended up being faster on your machine at the given time. So that's just a word of caution. Sure.
If there is a part of the data where you're querying a lot, for example, in this data, the test score number, and we have a fairly low amount of data. In this case, we have 3,000, which is not a lot.
Yeah.
Would you advise us to always create an index on this frequently queried data, or should we use index from such a number of data sets?
Okay, so the other part of index is MongoDB can only ever use one index at a time. If you have a small amount of data, then adding an index may actually impact your performance very, very slightly. But if you're talking 5, 7 milliseconds, then it's probably not a big issue for you in terms of impact here. But if you have larger data sets, obviously having to scan through each document is going to get slower and slower compared to having indexes where you can just go and find those documents and then go read that from those documents directly. So there's it depends on what your criteria are for speed. There is, this is probably more of an exercise for doing in the JavaScript shell, which is another ops type thing you can do, is you can actually turn on profiling, and you'll have to have a look up this in the docs, but there are different levels of profiling that you can have, and basically profiling will save data in a collection, and then you can go and query that collection at any point. And if you turn profiling on, you can have it every single operations profiled, and you'll work out how it'll give stats on what query was run, how many milliseconds it took to run that. Or there's a less verbose one where you can say only log queries that took over 100 milliseconds, or you can actually set the time yourself. And then you can go through them and determine if they need to use indexes or not. So this is when you're going in your testing stage, or when you have large data sets, you can see what the impact is compared to when you have small data sets. Everything works fast, to be fair. But when you're on a large sharded system, you want to be doing profiling to understand that your indexes are efficient and work as you do, or that you are using indexes and you're not doing full table scans. Right. Okay, so I think what we'll do is we'll move on from indexes and we'll go on to the next sort of doing updates as well. So if you want to know any more information, I think everyone should have got in their bags a little book on MongoDB and the MongoDB sort of commands book as well. If you want to know more about what the explain command gives you, there's documentation on the MongoDB website that will tell you things like what n means here, and n scanned and things like that as well. So basically n is the number returned, n scanned is the number of index lookups it did, and n scanned objects is how many documents it actually went and looked up as well. And but there's more information there that will help you debug and determine how efficient your queries are. So the next part is we're going to go and have a look at is lesson 1.3, which is all about updating your data that you have and removing data as well. So this is all very well being able to input it and being able to find it, but obviously the cycle of data is to be able to update it and work out how you're going to do that. So if we run through that, if you go and download the documentation there's a number of exercises to run. Now, one thing about MongoDB is you could just use db.things.save. So let me just make that a little bit bigger, give an example. So here, when we're talking about things, we're just doing save. And what save does in the background is it will do an insert or an update, depending on whether there's an underscore ID. Now, using save is great when you're creating a document for the first time. So if you haven't necessarily given it an underscore ID, that's fine, that's fantastic. Using save throughout the life cycle of a document is not as good. And the reason for that is potentially you can add a race condition, because what save will do is it will replace the whole document on disk. Now you may have other processes that are reading that document and also using save, and if they're running in a multi-threaded environment, or you have multiple processes running and one saves first and the next one saves, it will write over it because it will save the whole document. So the best way to do updating of your data is to use what we call the atomic update operations, which is using things like $set here, which is where you're setting a specific field rather than trying to reset the whole document. This becomes important when we do deal with things like arrays, lists and such. You have operators like push and pull to put things onto lists and get them back. So rather than saving the whole list, if you're just adding something to the list, you want to use the $pull operator and put that, the $push operator and put that onto the list. And that will ensure that the data is added atomically and that you're not going to lose data when you start doing and adding things onto lists. This comes, I've seen this a number of times where people are just using save or setting the whole list, and they'll do it in testing. They'll run thousands of threads and they'll try and create a list that's X long, and they'll continually save it, and when they go and have a look at it, they'll find out instead of being 1,000 items long, it'll be just 15 because of this race condition that they've created. So if you're dealing with lists, use push and use pull to put data on and get data back. And the same with if you have counters. So if you have any counter fields, use the $inc command to increment or by a positive or a negative number rather than just trying to reset it every single time. So if you go through and have a go at doing the updates, and run through those examples, please. As ever, when using IPython, you can always use help and have a look and try to see all the commands that you get for any of the given operations. So here I'm just doing help on db collection name.update, and it will give you information about the keyword arguments that you'll pass to it. Similarly, if you work through the removing the data operations as well, we'll pause when we come to the fire and forget and safe write operations, because there's a little bit more to explain there. But updating, you'll quickly see it's easy and easy to do, and similarly with removing data. There's foobar. Let me make sure I'm on. I had a question here if everyone can see this, where initially we're inserting a document with the values of foo and bar and giving it an underscore ID, a primary key. So when we find it, it all looks fine. And the next thing we're doing is we're doing an update here. Now, because we're not using any of the update operators, it's essentially doing a replacement of the whole document. So here we're saying find, the first part of update is the find query, so we're updating where underscore ID is 123, and we're updating the value of the document to be hello world. You can't change the value of an underscore ID because that's the primary key, so that's immutable. So when you next do a thing here going find one, we no longer have foo and bar in it, we've replaced all that data. So this is kind of a common mistake that happens, and it's not terribly clear either that this is going to be the consequences of your actions. So this is a kind of a common gotcha with MongoDB in general. So if you want to add a new field to your document, then you have to use the $set operation to set, and then you're setting hello to be world. So if you don't use the operation like set and update those ones, you are actually doing a replacement. This is similarly, you could run this on its own, this command, and then pass an upsert to it as well, because the update operator, part of the other keywords it will do is one of them is an upsert, which will, if it doesn't exist or if the query doesn't match anything, it will add a new document in based on those criteria as well. But the main thing to realize is if you're doing an update and you're not passing in a operator like set or whatever, then you will, and you're passing in a dictionary, you will overwrite whatever it matched.
So the way to delete anything is using data, ID, and set.
So if you did update ID to delete it, and just passed in an empty dictionary, all that will do is will actually just set underscore ID, and then it'll have no keys and no values in it. So that's not the same as deleting, because you have to use the remove command to actually remove that document from the database totally, but essentially you're clearing all the other data in that document.
No, but that could be used.
Yeah, sure. Sure, but the difference is people don't expect this to actually update the document to be this. They expect it to add. So yes, so when you go on down, we'll look at, here we go, we're setting hello and setting a value, and that will change and update single keys or add them. One other thing to note is when you do an update operation, you can do multiple operations. So you can set multiple fields at the same time, and you can do a pull operation at the same time, and you can do an increment operation at the same time should you need to. So you don't have to do pass through multiple update statements to do that. You can actually use the syntax to do multiple things on your data. So save is doing essentially doing in the background. It's doing the same thing as what this update was doing. Where do we go? What this update's doing here. So save, if you have an underscore ID, it will do and replace the whole document, which is very useful for short things and going through, but it does introduce race conditions if you have multiple people or multiple processes potentially updating that data at the same time. And the easiest way to see or get an explanation of it is just in the JavaScript shell. You can just, if you don't add the parentheses, you can see exactly what's doing. So if underscore ID doesn't exist on an object, and the Python will do a very similar thing, it will do an insert operation. If underscore ID does exist, what it's doing here is it's doing a query against that and passing in the object itself. And this true here means if it doesn't exist, do an upsert. So if it doesn't exist, add it anyway. Because in theory, you can set your own underscore IDs, and people do set their own underscore IDs anyway. So this upsert here will ensure that data is persisted. And the problem is this, again, as I hopefully have made the point, will overwrite any data that already exists. Any other operations that dealt or updated the object in between you doing it, that data would have been lost. Okay, has everyone got up to removing data? Okay. So the next aspect to understand about how MongoDB works and how write operations work and talk about durability of data is to understand when you do an insert what really happens. So MongoDB by default tries to do everything correctly in terms of how sensible defaults. Arguably, the fire and forget writes aren't what people expect, so most people will do something called a safe write. So when we talk about durability in MongoDB, when you do any write, update, or insert operation, it's done, all you're doing is you're throwing that data off. It's done asynchronously, and you're not waiting for a response. So you don't even know if the database got your update or insert operation. Now, that might be fine if you're throwing loads of data and the data has little value. So if you're throwing loads of log data into the database and it doesn't matter if you missed one because a socket got dropped or whatever, then that might be fine. But for most people, that's not kind of fine. It's not what you would expect from a database. So there are different levels of sort of write concern when you do inserts and updates to MongoDB. The first one is called a safe write, and basically what it does is it calls back and it does the operation and then calls back and gets feedback from MongoDB whether that operation was applied to memory. So safe just means MongoDB, did you get that data? Has it been put into memory? Doesn't mean it necessarily persists to disk. So that's our first sort of safe operation that we're doing. This first example here is doing an insert here and doing underscore ID and setting a value. Now underscore ID is a primary key. And as such has to be unique. So there we go, we insert some data, and the next thing we're doing is we're trying to insert the same document again. And it's not failing. But when we do a count, we only get one back. Now, the reason this is not failing is because we're doing fire and forgets. We're just throwing them over and going, right, do this, and we're not waiting or getting any feedback from the database. If we put a safe flag on and said, actually, I want to understand what's going on, give me information about that insert, then we'll get something saying a duplicate key error has failed. So until you start asking for feedback from the database, it's not going to tell you if there was an index problem, if something that was supposed to be unique got failed or whatever. So as we go through the next example, is we'll do the same thing again, and we'll pass in a flag saying safe is true. And this means that we want to ensure and get feedback from MongoDB, and funny enough, we'll do it and we'll print the exception here, and it's telling us that it already exists, there's a duplicate key error. Now, this is great. This really gets expanded upon when you start looking at things like replica sets and having a wider system. But to begin with, you can do safe is true as a right concern. You can set things like journal is true. At the moment we're not using journals for these examples just to keep the space low, but if you had journaling on, then if you do J is true, you'll wait until the data is flushed to the journal and the journal persists. So that means if anything happened to your system, i.e. it crashed or whatever, as long as the hard drive hasn't been corrupted or is broken, that data is recoverable on a restart. So for most people, journal is true is probably going to be a default operation that they would want. When you start having replica sets, so then you have multiple nodes, you can actually do cross-node durability as well, using the same thing, using right concerns as well. So you can say, I want to ensure that it's applied to 2 of my nodes out my 3 nodes, for example. And this can build up and allow you to have more durability of your data. Obviously, the longer or the different rights you go for and the different right concerns, the more blocking this operation becomes. But here I think we're just going to be using safe as true to ensure that it's applied to memory. Other operations you can do is you can actually ensure that a file sync happens, but this is one that I wouldn't advise doing because it will really slow down your performance. Which comes on to when do things like journals and when do the memory maps, RAM, when does that get flushed to disk? So journals get flushed to disk every 100 milliseconds or every 100 megabytes that go through them. So it kind of depends. The memory map files themselves get flushed to disk every, I think it's 60 seconds, so every minute. So if you care about not losing data, should the machine go down, then journal is true, is the best and most sensible operation that you're going to do. If you care about, later on if you've got a bigger system and you're doing replication and you care about if I lose a whole node and that database goes, then having a right concern of 2 might be the best operation for you. These kind of right concerns as well, you can set on many different levels. So you can set it on the connection level, you can set it on a database level, you can set it on a collection level, or you can do it on individual queries as well. So it kind of, these concerns, you can set defaults that you use everywhere and in certain places overwrite them. And similarly, when you come to read data in a replica set, or you can also determine where you want to read data from as well. You can read from a secondary or read from a primary, and those have the similar read concerns as well. Okay, any questions about that? Okay, so if we go through the examples, just run through them, and I think we have the exercises at the bottom, so we'll just ensure that. Cool. I'll just run through them just so greater or equal to... Okay, so the first exercise, all you have to do is you do a query where you put a range in greater than or equal to 90. So I have it on, let's just make this a bit bigger for people. So you are, if you have a score greater than or equal to 90, you're setting grade to A. And then you're passing the multi as true to make sure you do multiple updates. You're not doing the first one. And then when you go and have a look, you'll find that that now anything with above 90 has a grade of A. So how have people added 10 points to scores less than 60? Anyone managed to do that one? Yeah, that's right. So all you're doing is you're doing a similar update. So we'll do less than or equals 90, and then we're just going to go increment. Actually, remember the right way around for increment. Yeah, I may get it wrong. And we're going to increment score by 10. Oh, that should have been, sorry, that should have been 60 there, but yeah. And similarly, to remove all scores below 80, all you're doing is you're doing a the remove and passing a range function to that as well. Right, so we'll move on to the next lesson, which is aggregation and gridfs. So that's 1.4. Yeah, sure. Okay, so yeah, MongoDB doesn't have any transactions, so there's no undo. You can't roll back. Yeah. And I did it, for example, here I did it wrong. Then in here I would just, yes, that is difficult, so I'd find that anything that is undoable essentially, because anything above 90, if I did a query where actually it's anything less than 80, take 10 away, I would take 10 away from those ones that weren't part of that query range. So there are no transactions, there is no rollbacks in MongoDB, so yeah, tests are the best way to protect yourself from user error like I've just done. Okay, so can you create users with different privileges? No. So there are certain commands. I think you can stop people. You can stop people creating new database files essentially, but you can't stop people creating collections when they do db.collectionName. None of this is enforced. In fact, the only user security that we have is you can set up a username and password essentially for being able to log into the JavaScript shell or being able to log in by PyMongo. But there's no role-based what they can and can't do. That just simply doesn't exist at the moment. Whether it will exist in the future, I don't know. I imagine it will do, but again, maybe 3 years, 5 years down the line, who knows? It's not necessarily on a roadmap that I know of now. It may be, there probably is a ticket in Jira for it, but it's unplanned into what release it will go into. So one of the things you'll see is when I go and speak to customers and go and talk and do consulting is when you have a look at their database, they'll have a, in fact, if I do a, is it collection? If I do collection names, what you'll do is you'll run this on their database and you'll find that they, not only do they have the indexes, which is fine, they'll have a scores database, but they'll probably also have a score database as well without the pluralized S. And it'll be someone somewhere has created that for some reason, inserts some data. And that may be fine, just in a test environment. They may have cleaned up their code. But one thing potentially you might want to do if you add monitoring is to ensure that the response back from collection names is what you expect and that no one has gone and created one without it. But you have to manually do these kind of operations. There are no restrictions in stopping users, really.
So I want to play around with my data, with my collection, and it's a, let's say it's a big collection. Can I create a test database and I'll move some documents?
Yeah.
Can I do it like select a random number of documents and just move it around the page? Well, something I will need to do with Python.
Yeah, I mean, you'd write the code and you'd set whatever random is and maybe put a limit on that is random and then set them and save them somewhere else in another collection. I mean, certainly that's possible. But this is kind of, a lot of things you'll find are, if you want to do anything outside of just using and updating, you'll have to write your own application code to deal with that. So one thing for an example is there any rollbacks? Well, certain libraries will have things like versioning of documents. So every time you update a document, it'll increment a version of it, and basically you just have multiple copies of that document. Whether that would stop and deal with like you running an update query is difficult to work out, but in that instance, if you're just doing a global update, versioning won't help you. But if I had a version in, or if I created a new document, then potentially it would. But then you have things like race conditions potentially you have to deal with of multiple people creating new versions of documents. You may get clashes and have to deal with that in your code. Also, people have written code to deal with transactions in MongoDB and manually roll stuff back. That's not a feature that we have, and you have to, it's something you can write in your own code, but it's fragile, it's expensive, and it's not really using MongoDB necessarily to its full merits. So you have to maintain that code. But it depends on your use cases, and as MongoDB is extremely flexible in terms of schema design and how you set up your documents, it's difficult to have and say what is the right use case. It all depends on how you're reading your data and how you need to use your data. What I'll do is we'll go through, we've got 2 more exercises to do on just PyMongo, and then I think I'll throw open do a bit of Q&A, and then we might start looking at the Mongo engine, which is an ODM wrapper on top of PyMongo, and do that. But I doubt we're going to get through all the exercises, but they are downloadable. You should be able to run them, so you'll be able to take them in your own time. But the Q&A might be a better aspect to get more information out of me, or more information generally about MongoDB as well. So moving on to aggregation, which is 1.4, the PDF here. Again, we're creating a new collection here and we're inserting some data. And the first part of aggregation is something called MapReduce. So what MapReduce does is you provide JavaScript functions that are run on the MongoDB server, and then it will return you the result set back. You have to use a certain Python type to declare things as functional codes that can be run in the JavaScript engine. You provide one function to do the sort of the map part that will emit some data out, and then another function to do the reduce part. You can also have a finalized step as well, should you need to. The difficulty, or one of the main complaints about MapReduce is, or two of the main complaints about MapReduce is, one, that you have to learn JavaScript to do it. So if JavaScript's not a language you're familiar with, that can be painful. The other part is it does run on the server, but it runs on the JavaScript engine in the server, which is single-threaded at the moment because it's using SpiderMonkey, so you can only run one MapReduce process at a single time. And also the cost of translating the documents from BSON, which is the binary JSON, in and out of SpiderMonkey back to C++ is kind of expensive. So we'll go through and do the MapReduce function and run through that code. And then the next thing is a new feature that's upcoming in 2.2, so it's in the unstable release now, called the aggregation framework, which is, well, I'll go through that when we come to that. But if you're not running the latest and overnight stuff, you won't be able to run the aggregation example, but that's not a problem. I'll just run through what kind of things you can do with it and explain it, and hopefully that'll pique your interest for the new release up and coming. So if we run through the initial examples and have a go at doing the MapReduce and run that example there. So let's explain this code here. So once you've inserted the data, so there's some example documents at the top, which is just like some very simple examples here that all have tags, or the last one just has an empty array for tags. So what MapReduce does is you're running JavaScript functions, and this is the map function here. So what that wants to do is that wants to emit a value, and then so for every instance of Z, which is for every tag, we're creating the tag here, we're emitting the tag value, and then we're emitting something else. So when it comes to the reduced function, this is the key, and this is the value. The reduce function takes the key and all the values, it creates an array of values for each of those, emits essentially, and then runs through them, gives you that array, and here we've got a total, we're going through all the values, the array of values, and then we're just adding the total to that value. And we're returning the total. So when we do the map reduce, we're passing the map, the reduce, then we're getting out into a collection. You can also do it in line. so you don't have to cast it out into a collection or persist it to disk. But if you do cast it out into a collection, you can run multiple map reduces and keep on aggregating data over time. One of the difficult things at the moment is pre-2.2. This won't work on a sharded system. You can't map reduce across a sharded cluster or a collection to get that data back and persist it to a new collection. In the future, you will be able to. And when you run it, you'll see that it's basically summing up how many cats there were, how many dogs, how many mouses there were. One thing it hasn't done is it hasn't given us the empty one. So the reduce function, actually I'll leave that aside. There are some quirks to running it. Reduce is only done if there's multiple values, essentially. So if there's not multiple values, essentially you might have to recast your document here as you'd want it, depending on what kind of aggregations or functions you're running. There is a third step you can do. You can do a finalize step where you get the actual results and do some cleanup should you need to, and return that and clean that data up. This is a very simple, just doing sums of tags that you might do for, I don't know, a tag cloud or something like that. What is painful is if you do something larger, if you want to start pivoting data or doing, I don't know, finding out the first value in a series, the last value, mins and max and averages, debugging this is painful. So unless you're good at debugging JavaScript and you can write your JavaScript well, then it is a real pain. Which leads us on to the aggregation framework, which is coming out in the next release. It's available on Unstable now. And basically, the aggregation framework allows you to provide a list of operations that you want to apply to your data. So there's a lot of stuff you can do with it. It's very powerful, but the good thing is it's very declarative as well. So you give, and similar to how you write your queries, you can project data out and give examples of how you want that data to look, or you can do aggregations, you can unwind arrays, and there are like a few examples to have a look at. But this is doing the same thing as we were doing previously, where we're grouping the tags and then we're summing the value of tags. So it's a lot easier to run once you have it. If you don't have 2.2 installed, these examples won't work. And currently in PyMongo, there's not a helper at the moment. There's not like db.things.aggregate. That's going to be released when 2.2 gets released. So to be able to run it, you have to run the command manually, which is you do db.command, and then the aggregate command, the collection you're running it on in the pipeline. In the background, all commands in MongoDB are simply commands. They all work similar to this. So if you do a db.collection.find or an insert, there's going to be a command. It'll convert it into a command essentially, or many of these operations will convert into a command and we'll run it on the collection. They're just helpers in the shell to make it more, well, easier to use. So this is just doing a simple, doing the sum. It's not a great, well, it's an easy explanation of the aggregation framework. Some of the other things you can do, which make it more powerful, is you can reproject and cast things from arrays up to a top level, or recast and recreate your documents as you need to use them. It doesn't change any data on disk, so this is all applied on memory, in memory, and returned back as like a result set, as you can see here. But things you could do, if you had a blog and you had an array of comments for that blog, and you wanted to find all the comments by Ross, for example, currently you would do a query and go comments.author is Ross, and that will just return you all the documents and any comments by, and all the comments for that document. It doesn't limit sub-fields, which people kind of want to do. So the aggregation framework, instead of having to do it in your own application code and going, right, remove all these comments that aren't by Ross, you can actually use the aggregation framework to unwind the comments, do a match where the author is, and then rebuild them, push them back into an array. So you're just doing the same thing as you might have done in your application, but doing it on the server instead. Yeah, that's right. But this is a select of a subfield and reproject. Similar to how you can project and create new documents. You can totally change how your documents look depending on how you want to use them, which may allow you to remap data or have other uses of data.
Here, the sum column 1 at the 1 is registered as a boolean, right? That's true. And we want to sum, we want to increment by 1 every time we...
Okay, no. So, well, sum is just true, essentially, this value here means. So you're doing basically underscore ID of the group by query is what you want to group by, and then we're just creating a new field called count, and then the count is sum is just 1, is just like, the count actually just means sum. But because of the way MongoDB works, that essentially means true. Sum is true. And then we're just doing a sort at the end just to clean up the order that we get our data back in. There is a lot, I mean, do have a look. If you need to do more aggregations, then potentially it's useful. There are limitations coming in 2.2, so you can only do aggregates inline, so they're not saving it. There's no way to write them to a collection. You'd have to do that in your application, which limits how much data you can deal with to begin with. But hopefully people will like that a lot more. There are other things you can do. You can do math operations, you can do date operations, you can get information from dates as well and do other things with that. So if you need that, it's a lot quicker and easier to do than in MapReduce. And it's faster as well, because it doesn't have to translate documents in and out of SpiderMonkey. Because not everyone has that aggregation, doesn't have the aggregation framework, I'll just go straight on to GridFS. Now, if you didn't know, MongoDB has a limit on how big a document can be. It's currently 16 megs, so you can't have a document that's bigger than that. Which is probably good if you're returning lots of documents over the wire. 16 megs is quite a lot. But people also want to store files in MongoDB. So there is a convention built on top of how the collections work called GridFS, which is basically a file system that stores your data in MongoDB, and basically it chunks up the binary data of your files, stores them in one collection, and stores metadata about your files in another collection. So if you run through and have a go at using GridFS, what you'll see is when you do get collection names, you'll get one that has the meta information, which is just a document about saying where the files exist and the ID of the file, and you can add information there to annotate it. Say it's give some information about the type of document or the content type you want to use, and then another collection which has the chunks of the file going through. And we have a wrapper that you'll wrap through, and you can read in Python and write to these files as if they were just native files, essentially. Once you're using and connected to the database, you can just go put and read from those files. So if we go through, we're going to try and run these exercises here. If anyone's got any or needs any help with this, give us a shout. The first exercise is really for using the aggregation framework, because writing a pivot in MapReduce is quite a lot of JavaScript code and probably more pain than it's worth. But We'll have a look. So I've just been asked about how, or to give more information about the aggregation framework in terms of using it. So, and what unwind does. Basically, one of the other brilliant things about the aggregation framework is it's easy to use because you can just continually work through your examples, and it's easy, that makes it easier to debug. So if we just throw it in, do an unwind, and just do one of those operations, we'll get our information back. Unwind, what it does basically is for each instance of that array, will cast out the single instance in the resulting document above. So, for example, we'll see the object ID being multiples of them, because when we're unwinding, the first, where x is 1, has the tag dog and it had the tag cat as well. So for each instance of the tag, it will cast it up into the top level and just repeat those values. So you can then go and do things. I mean, it's kind of, for here, what we're trying to do is we're going to explode that data set out, and then we're going to collate them back and group them as single and so we can count them. I have to remember how to do this now. Use tag. That's not right. Right, has everyone managed to get a file in and out of GridFS? Or just some text in and out of GridFS? Still doing the aggregation, okay. What I'll do is, we have half an hour left. Is that right? Okay. So, I'll just do a quick review of this, then we'll spend 15 minutes on the next exercise just to give some understanding there, and then we'll do 15 minutes of Q&A rather than worrying about the Mongo engine extra lessons as well. As you can see, you can run through all these through the PDF anyway, so they should all be runnable. I've written them in IPython notebook, so they should all work. So, but we'll go through them in a moment. So, the first exercise was, if you had aggregation, run a command to pivot the data and group each tag. It's slightly complex, but I have to run through and find in my history. What I've done is I've unwinded the tags and then grouped each individual tags, and instead of pushing them, I've done add to set, which is just to ensure that they're unique. So I've added to set, and this essentially will pivot my data out. So for each tag, I now have all the X values that are used in that tag as well. So the first operation was unwinding, the second operation was grouping by the tags themselves, and then I'm basically pushing each value of X onto an array. But I'm using add to set to make sure they're unique, so I don't have multiple values where they use it. Implement the group example. If I'm honest, and I work for 10gen, and I don't really use group at all, so this one I struggled with. It's the first time I think I can actually remember running a group command. So, and basically there's a helper that allows me, and I had to have a look at the help for the helper a lot. I can group by the tags, so you can have multiple values. I'm doing a count here, with this is the initial value for count for each one, and I've got some JavaScript function that runs. And so where tags is dog and cat, there's one value of that, and because of our documents there's only one value of each one anyway. But it is a potential way of aggregating. I don't see it much in usage. People don't use it as much. I think it has limitations with things like when you're out on sharded systems anyway. So a lot of people will use MapReduce rather than using this group function. I think it more shows the evolution of MongoDB in the last 3 years and how these functions are done. And I have a feeling at least the group function will be deprecated for the aggregation framework anyway. MapReduce probably will stay around because there's a few things you can do in it that you can't do in the aggregation framework, but its usage will fall in the future. Storing a file from a directory and reading it from GridFS. If you haven't done that, you can work through those examples. It's exactly how you would store a file, but you'll use connecting to the database itself. Do you want to see the group one again? But this is not even as useful as the MapReduce example, because you're just getting each. You want to explode out those tags if you wanted to do the count of each of the tags. Have you got that? Nearly? Okay, good. Yeah.
When you use a GFS, you are casting MongoDB document.
So when you're doing, no, actually you're putting something that's iterable and file-like. So for example, you want to be putting a file onto the system. So if you read a file and you put the file, here we're putting a string in, but in theory it could be a file object that would get rid of, that you would read through and it would iterate and persist that to disk. But essentially what we're storing here is this is going to create a document, a file essentially that has the value of hello Python. So this is the value of a file. So when we do the read of the file here, let me just scroll that up scroll up so people can see. So in 7, when we're reading a file essentially, and there you go, and that's the contents of the file. because we split these files up as well, you can seek forward and go forward and jump through the files relatively efficiently, but it's not going to ever be as efficient as a network file system potentially, but if you need it and you need the durability of it, it can be extremely useful and simplify your stack. It depends what you need to use. Reading these files out of your application and reading them out of Python can be expensive because you have to read the file and stream it back. So if you're just storing them in MongoDB, what people will do is they either use the Nginx plugin that can read straight from GridFS from the ID and stream that data out, which is a lot quicker than going into Python and then streaming it from Python. Or other people will put it behind a cache, something like Varnish as well, to stop it having to hit and read from the database to speed up those responses. It's not going to replace the network file system, but it allows you a level of flexibility and is just something useful that you may need in the future depending on your use cases.
To be true, the first use case that it was doing was completely the opposite. For example, there is that Adobe program Lightroom, which is to manipulate photography and the like.
Yeah.
It stores every photograph in a SQLite database. So probably this could be the
Yeah.
not using that. Is that what? Just a block.
Yeah, so I mean, the good thing is it will chunk out those blocks, so it allows you to read through them relatively efficiently. GridFS will work with replication, so you will have the high durability of it. It will work with sharding, so you can essentially, if you have a massive file store, split them up and do it across as well. So there are some really nice aspects to it. It's just, again, you're storing data and you're storing files in a database, and that will have limitations from storing them on something that is essentially a file system. So. Right, so we've literally got a few minutes just to talk about commands, and there's some examples here. Right, so in the background, all the drivers will run, essentially will call commands to run and to run operations against MongoDB. And if, like the aggregation framework, because it's so new, there's not a helper for it in the driver yet, you actually manually call the command itself, and you can find out more about the command and the arguments by looking at the JavaScript shell. Some of the operations things that you may need is, and we have some examples here, where we're calling things and getting the database stats. So if you're planning to use your database and want to know how much room you'll need, and you have a level of data in there, you can extrapolate from the stats, the DB stats, how much disk space you'll need over X period of time. So there's just some operational stuff that gives information. Tells you how big the file size is, how big the index is, how big the documents is, how big the storage size is, so how much the actual data is, and then how big the file size. The file size is all to do with pre-allocation. You can also pass in, as another part of DB stats, is you can put in a scale thing to scale out these numbers to be more meaningful than bytes. But you should know this, if you ever have to come to plan out when you need to shard or when you need to do replica sets, how big your boxes should be, how much RAM you need, then things like the average object size is important to understand. If you grow and your documents grow and you have 10 million documents, you can times it by 10 million, and that'll be essentially how big the data is going to be on disk, and then take into factor how big the index is. You can work out if you need everything in RAM, potentially you might have to start sharding that data out to deal with it. And again, similarly, you can find information about the collections themselves, so the individual collections. Rather than the whole database, you can have a look at the actual collections as well. So I'm not going to go on too much about them. Another interesting feature about collections that exists is something called a capped collection. So a capped collection is limited on size. It has no indexes by default, so it doesn't have an underscore ID in the index itself. And it basically works as a queue. So it's first in, first out type thing. You set how big the size you want that capped collection to be, and once it's set, you can't resize it without actually creating a new capped collection and re-importing the data essentially. It does have some nice features. What's used for replication essentially is a capped collection itself called the operation log, the op log, and what the secondaries will do is they'll have something called a tailable cursor, which we'll come on to in a moment, which will look for operations that happen on the database and then apply them to themselves. But should you need to do any sort of pub subbing or anything like that, potentially tailable cursors and cap collections might be what you need. So in this first example, we've set a cap collection up. All you have to do is put caps as true when you create a collection, and we've set the size. So it's a very small collection, as you can see, and here we're adding 1,000 or 999 documents. But when we do a count, we can see we only have 59 of them left in, because essentially all those ones as we're adding, it's pruning them out as well because there's not enough room for them. So the only thing to be wary of, this is size-based, it's not time-based. But it can be really efficient for if you want to see if operations come in and monitor and do things. So the next part is something called tailable cursors. With a capped collection, you can add, when you do a find command, you can add a keyword saying tailable. And here we have a loop. While this cursor is alive, ignore this run part here, we're going to try and get the next document off that cursor. If we're at the end of the iteration, we're just going to sleep for a while, and we're going to keep going through this loop. So if you ran this and had run is true at the top, this is so I don't break this application, but if you ran this and then started adding data in, you would see it would start printing out as that data gets added in. So essentially you have a long running process and you can do whatever you need to do with it. So one of the examples where people use this in the real world is with op logs and using something. They need a search engine. MongoDB doesn't have stem searching at all, so they'll use something like Lucene-based, Solr or Elasticsearch. And people have, instead of doing a bulk run, going load all my documents, convert them into and put them into Elasticsearch, what they'll do is they'll have, on the operations log, they'll have a tailable cursor like this. They'll wait for updates to a document or inserts of a document. And every single time that happens, they'll go and fire off and say, right, now put that document in my, or update that document in my Elasticsearch. So it kind of, we don't have PubSub like Redis does, but people have worked around it by using similar things like this. Because we are so short on time, these exercises you can go on and have a look at your own leisure. So have a look at looking at the stats. You can understand why there are only 59 documents in the cap collection, because we've run out of size, so it's overwritten. You can have a look, find out what indexes exist on a cap collection. There should be none by default, so it doesn't have an underscore primary ID index. And the other thing is, tailable cursors don't use an index. So even if you set one up on a cap collection, it wouldn't get used in a tailable cursor. And if you try to create a tailable cursor on any other collection that is not capped, it'll throw an error. So that's the results of those exercises if you're going through. This is kind of advanced, and not many people use these outside the op logs, but if you need one, or if it's a use case where you have a fixed size, you want to do something based on it, it might be good. So I have now uploaded some other PDFs about MongoEngine. I'll just do a very quick introduction to that, and then we'll do some Q&A. We're not going to run through these. We don't have time to run through these here, but basically, MongoEngine is an ODM written on top of PyMongo. I'm the maintainer of it. It was written by a guy called Harry Marr, who's about as well. There are other ODMs that are all good for MongoDB and Python as well. But the reason why you might have one is interesting. So if you're working in a team with MongoDB, you may want to, or you may find yourself, if you're just using the native driver, writing a lot of schema validation to ensure that the schemas look the same. Even though it's schemaless, most people will have a default schema for a user. They may have some fields that may or may not exist, but things like usernames are always going to exist, and email addresses are always going to exist, that kind of thing. So MongoEngine allows you to, after you install it, allows you basically to define schema. And here's just an example. And if you're used to using Django at all, and Django's ORM, it's very similar to that. So the way you query and find data is an abstraction on top. So one thing about defining your schema as well is it allows you to create forms quickly and easily based on the expectations of your data as well. But other features that Mongo Engine has is it supports inheritance, so you can have multiple documents and different types, and basically you may want to use it for where you want to enforce schema essentially, or allow other people to pick up and understand what the schema of your database is, so have it documented. It is slower than using the native drivers, obviously, so there's one gotcha there. So if you need speed, always use the native drivers anyway, and there are some things that we will fix in the future. If anyone's got any questions about Mongo Engine, either dive onto IRC, chat to me. I'm doing help desk this afternoon, or any questions in general, you come and see me then. So I think what we'll do, these files now, for all the lesson 2 stuff, the Mongo Engine stuff, they're available from files.ep as well in the PDFs, so you can go download them at your leisure. I think the best use of time now for the last few minutes is just to do some Q&A. So I did have a question about organisation, I think, was it? So yeah, do you want to fire your question again? So this is all kind of, it's about organisation. How do you form your collections? Documents all look different. What are the best practices, I suppose? Well, collections should only store things of a type. So they may look different, the documents, but don't use a collection as a one-size-fits-all bit of data. So if you have users and you're storing all your users, store them in a users collection, that's fine. If you have posts, because it's a blog, store them in a post collection. Just use namespaces to be explicit about what you're trying to achieve. The next part comes to schema design. When do you use lists to store data and sub-dictionaries, and when do you actually go and put them in a different database or a different collection? So schema design is one aspect that is all about how you use and how you read your data. So if you're reading from a database a lot and your updates are infrequent, then the schema design is you want to have your data exactly how you need it. So using things in an array might be the perfect schema for it, because you can do one query, get your data and throw it straight out into the front end, and then iterate over that data, and that should be fast and efficient. But if you had a blog post and you had lots of comments in that post, and those comments were a list, and you wanted to find all the comments by a user because you've written a forum or written a site, then that's less efficient, because you have to find all the documents that match, filter out all the comments, and that can be expensive as you scale and scale. So because we don't have joins, you have the choice of either embedding, or you can just have it in another collection, and then you'll have to manually go and find all the comments that match blog ID, object ID, that kind of thing. So you have to manually, and that'll be 2 queries that you'll run. But the cost of that is you have to do 2 queries to display your information, but it allows you to query and get at that information in a more ad hoc manner. It allows you potentially to do aggregations on that data easier as well. So it kind of, the schema design is complex in MongoDB because it's all about your usage. There's no hard and fast rules. You could have one massive JSON document up to 16 megs, which could be quite massive, that has a huge tree or whatever information you want. It's just not going to be queryable, not going to be very useful unless all you want to do is read and output that data. So those are the kind of gotchas that you'll get with regarding schema design. Any other questions?
Replication. Is there any utility where I can just go across and flip over my databases to another area?
Okay, so replication, this is kind of aside from the Python way of doing stuff, so this is aside from the driver. What you'll do is when you run MongoD, you'll give it a name of a replica set, and you'll pass in, it's just a command line argument, you'll go MongoD, so you'll run the daemon, and you'll go -- replica set and give it a name. So what that will do is that will create the operations log to allow you to start storing operations that happen, updates essentially. The next aspect of that is you go into the JavaScript shell, and you wouldn't do this via Python, but you'd use the JavaScript shell, and then you'd set up configuration of that replica set. So you'd give where the hosts are. So you'd name all the hosts, and then you'd initiate the replica set. And when you initiate it, so you can go from a single node with lots of data, and then you'd set and configure it all, you'd initiate it in the shell, and then any other nodes would start pulling that data across. So they'd replicate all the data to begin with and be in a state where they're essentially recovering. So they're copying the data, and as soon as they're available to start reading from the operations log, so they have that data to begin with, they'll start tailing that operations log and applying those changes to themselves. So going from a single system to a replica system is essentially really easy. It's like a 5-minute job. As long as you have your machines up and running, it is super quick. How long it takes for you to get that data across depends on how much data you have. If you have a terabyte, you have to drag it across the network. That can be slow. You can do other things. You can dump the database itself or use a backup to restore your new nodes and then get them part of the replica set as well. And they won't have to drain all that data across. They can just, if they're within time of the operations log, just use that to update and recover. I probably will be talking tomorrow when I do a talk about MongoDB, just in creating your first application with it, talk about some of the replication and sharding aspects as well, in a little bit more depth. So there should be some. I know there was a question about sharding as well. Was that you or? Okay, you asked about GridFS and sharding. That was right. So sharding is all about sharding not a database but a particular collection. There are intricacies of how you will do that. You may need downtime, you may need code changes, because basically you'll say I want to shard a collection by a key, and if you do inserts and you don't have that key, then you're going to have to update those so we know how to shard. But essentially that is a whole system built on top of replication kind of, and has its own managers and balancers. Cool. Any other questions? A random back. No, I don't think there is a helper at the moment. Say randomly give me an object. I mean, you could randomly limit, but you'd have to know what the count is and stuff like that. So there's no easy way to say randomly give me any, other than writing application code to do it. Theoretically, you could use the natural sort order, but that'll be as things get listed, and then potentially stuff gets moved around on disk. But that's not really random. So, yeah. You'd have to do a limit and a skip and base those based on a count and say randomly give me, if I do a count and I know there's 1,000 objects in this database, so that's one operation. Next operation is give me a random start point and limit of 1 in between 1 and 1,000, and that's the only way to do it. So you skip randomly, but yeah. There's no operation to go via the shell like in MongoDB, like in SQL, which just go give me the random, I don't care which one it is. Again, it depends. Skip is going to have to traverse and go through the documents that match, so it depends on how good your query is to how easy you can skip. So if your query is all resolved within an index, then you're still going to have to go through the B tree and find whatever position you're going to. So if you're skipping to 10,000, you have to find out where 10,000 is. So, and if you don't have an index and go through, you're going to go through 10,000 documents to work out potentially where to skip to, because you might have to evaluate the criteria against those documents themselves anyway. Say that again? So the problem was, if I want to return a random document from the database, there's no helper to do that, I think, essentially. And there isn't. So you can write a Jira ticket, and there might be a Jira ticket about, so any features, just, yeah, if you need a Jira ticket, do that, and then, or there might be one existing, watch it, vote up for it. That's kind of important, is how us engineers determine what popular things are and what things we need to do. Cool. Any other questions? No? Okay, well, thank you very much, guys. Thanks. We are running a help desk this afternoon, so by all means, if you come up with any questions over lunch, just drop by and we'll be able to help. Thanks.